Okay, 3.4, we are reviewing the quadratic formula. The quadratic formula can be used to solve any quadratic equation, and whereas factoring and square root and completing the square are useful in certain times. Okay, to use the quadratic formula, the equation needs to be in standard form, equals 0, and then you can use the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's look at the first one. This is in standard form. So I'm going to identify A, B, and C. You don't have to write it, but you do need to know which one's which. So in this case, A is 5, B is 9, and C is 2, because it's 5x squared plus 9x plus 2. Okay, let's look at the formula up here. We are solving for x, because that's the variable. So I'm going to say x equals. Okay, in the numerator, it says negative b. B is 9. So negative b is negative 9 plus or minus. Then it has a big radical. Okay, inside the radical, b squared minus 4ac. So b squared minus 4a. A is 5. C. Okay, the fraction extends the whole way, and at the bottom there's 2 times a. 2 times a, what's a? A is 5. Okay, let's simplify this. So I have negative 9 plus or minus, I'm going to simplify the radical. 9 squared is 9 times 9, so that's 81 minus 4 times 5 times 2. I'm going to multiply all three. I can do it in any order. So 4 times 5 is 20. 20 times 2 is 40. Okay, now the order doesn't matter. So if I had done 2 times 5 is 10, and 10 times 4, I would still get 40. Okay, the entire thing is over 10. Okay, let's subtract the radical. 81 minus 40 is the square root of 41. The whole thing's over 10. Now let me look at the radical. Do I know the square root of 41? It's irrational. Can I simplify it? No, it's a prime number. So even though it looks weird, this represents our two answers. One of them is negative 9 plus the square root of 41, the whole thing divided by 10. The other one's negative 9 minus the square root of 41, the whole thing divided by 10. Okay, hopefully you remember that from Algebra 1. Let's try the next one. Okay, let's look at B. X squared minus 3x plus 10. In standard form? Yeah. Let's identify A, B, and C. And you don't have to write them, but you do have to plug them in. A is, well, it's just x squared, which means this is 1x squared. It's minus 3x, so B is minus 3, C plus 10, C is positive 10. Okay, I'm solving for x, so we're going to go x equals, okay, the formula negative b. Negative b. B is negative 3. If I do negative 3, the negatives cancel and I get positive 3. Plus or minus the square root of b squared. B is negative 3. Put it in parentheses because you're squaring the negative and the 3. B squared minus 4ac all over 2a. Okay, let's simplify it. Okay, so I have 3 plus or minus. In the radical, I have b squared. Negative 3 squared is negative 3 times negative 3, which is positive 9. The negative had to be in parentheses because I'm squaring the negative. Negative times negative makes it positive. Minus, okay, 4 times 1 is 4, and then times 10, I get 40. Okay, and the denominator, 2 times 1 is just 2. Okay, let's go ahead and subtract the radicand. 9 minus 40 is negative 31. Okay, which is weird, but we know that we're in the unit with imaginary numbers, so we're not going to panic. Okay, so let me think. This is going to be an imaginary, well, it has an imaginary component. So it's an imaginary square root of 31. The square root of 31, can I simplify that? No, it's irrational, so I'm going to leave it as imaginary square root of 31 The whole thing is over 2. Let's look at C. Okay, C is definitely not in standard form. Okay, I need it to equal 0. It actually doesn't matter if it equals 0 on the left or the right. So I just look and see which way I'd rather move it. I like this 2x squared being positive, and there's only 2 things over here. So I'm going to go ahead and cancel the 4x over to here. And that plus 2, I'm going to minus the 2 over to here. So now I have 2x to the second plus 5x, 11 minus 2 plus 9 equals 0. Now it's in standard form, and I can see that A is 2, B is 5, and C is 9. Now let's use the quadratic formula. Okay, x equals negative b plus or minus the square root of b squared. Now when b is positive, you don't technically need the parentheses, but I do them because when it's negative, you have to have it. So I might as well get in the habit. So what was that? B squared minus 4ac all over 2a. And then let me go ahead and simplify that. 5 squared is 25, minus 4 times 2 is 8, times 9 is 72, all over 4. So 5 plus or minus 25 minus 72. What is 25 minus 72? Let's do 75 minus 25. 47, negative 47. Okay, it's all over 4. Okay, negative 47 is weird, but it's not a problem because we've learned how to deal with imaginary parts. So I lost my negative. Negative 5 plus or minus the imaginary square root of 47 all over 4. Okay, I'm going to do one more with you. Okay, d 3x squared minus 7x equals 1. Not in standard form. It doesn't matter which side I make 0. Since this side only has the 1 on it, I'm going to go ahead and minus the 1 over to the other side, which is going to give me 3x squared minus 7x minus 1 equals 0. Okay, so what do I have? I have A is 3, B is minus 7, and C is minus 1. And you don't have to write it every time, but you need to know what it is. So x equals negative b, negative 7, positive 7, plus or minus the square root b squared minus 4ac all over 2a. Okay, let's simplify this. I'm going to go lower. Positive 7 plus or minus negative 7 squared. Negative times negative is positive. 7 times 7 is 49. Minus, oh, well, this is minus 4 times 3 times a minus 1. If I do the minus times the minus, it's going to switch it to a plus. So let's just do the sign now. Let me do the numbers now. 4 times 3 is 12. 12 times 1 is 12. So it's 49 plus 12. The whole thing is over 6. Okay, let me simplify the radicand. 7 plus or minus 49 plus 12 is 61. Square root of 61. The whole thing over 6. Square root of 61 is irrational. I don't think it's simplified, so let's leave it like that. Okay, go ahead and try the practice problems. Unpass when you're ready to check. Okay, for number 1, I got negative 3 plus or minus the imaginary square root of 19 over the whole thing over 2. For 2, negative 3 plus or minus the square root of 41, the entire quantity over 4. For 3, 1 plus or minus the imaginary square root of 39 over 10. Now for 4, I did it 2 ways, because I could see why you might do it one way or the other. Okay, I like to keep my x squareds positive, so I minus the x and I minus the 3 to the left, which gave me this. When I do that, I get 1 plus or minus the square root of 61 over 10. If you looked at it and you said, oh, I'm just going to cancel this to the right because it's only one thing, I would minus the 5x squared on the right side, which would look like this. Okay, I end up with negative 1 plus or minus the square root of 61 over negative 10. Because this is a negative over a negative, this makes it a positive 1 over 10, which is the same as this. Now, if I do plus or minus divided by a negative, it changes signs, but it's still plus or minus, so it doesn't make a difference. So this answer is exactly equivalent to this answer, and it wouldn't matter which way you moved it.